So here we're given triangle DEF, and we're given some values here. I'm going to start by sketching out this triangle. Looks like we're given all of these side lengths. And so I don't exactly know if, it's obtuse or acute or it's definitely not equilateral, but I just want to make sure that we know that this is not to scale. I'm just kind of sketching this out to give myself a visual because I don't know any of my angle measures yet. So they're all pretty close together, so we'll call that good. And now, since I have all three sides, if you did number 2 on this one, you know that we can't use law of sines because we don't have any opposite values. No angles opposite of sides, which means we have to rely on the law of cosines. So I'm going to go ahead and try and find this angle right here first, which is opposite of E. So we'll call this angle E. And I'm going to make sure that E, or 22.7, is the value on the outside because they are the opposites of each other, meaning 20.7 and 21.2 have to be my A and B values. I'm going to run out of room here. I've made a huge mistake. Cosine of E. Sorry. I'll rewrite it here after I do a little bit of calculations. So in a calculator here, do some number crunching. 22.7 squared is 515.29. And 20.7 squared plus 21.2 squared is 877.93. And then all of this, so 2 times 20.7 times 21.2 is very close to the same thing, 877.68 cosine of the angle we're looking for. So try and not erase my triangle here. Oh, I did it. Okay, so from here, my calculations, I'm going to subtract 877.93 from both sides. So 515.29 minus 877.93. And then I get negative 362.64 equals negative 877.68 times the cosine of our angle. Now I'm going to divide by 877.68. And I'm going to leave this exactly in my calculator, but we get about 0.4132 equals the cosine of my angle. So I'm going to do the inverse cosine of both sides, which gives me my angle of about 65.6. 65.6. So there is my first calculation. I now need 2 other angles. Law of cosines a little bit, just a little bit much. So I would rather use law of sines here now that I have an angle. So I'm going to do sine of 65.6 over its opposite side, 22.7, equals 20.7 is D, so we'll call this angle D. So angle D here is going to be what we're looking for, and that is opposite of 20.7. So now I multiply 20.7 to both sides, sine of 65.6. As you get better at this, you'll be able to kind of just plug this stuff into a calculator and not have to rewrite it 100 times, kind of like I'm doing here, but it gets a little bit tedious, and I understand that. Once I do all of this here, I want to solve for the angle, so I'm going to do the inverse sine of both sides, so sine inverse of that, and I get my value of D, which is about 56.14 as my angle measure. And now my final step is to find the last angle, and since all 3 angles have to add to 180, I'm just going to do 180 minus 65.6 minus 56.14 to get my last angle, minus 56.14, and I get my final angle of 58.26. Be careful because these are all like rounded values, so it's not exactly that, but for the most part, that's our angles and our solved triangle.